Okay, this is what we were doing for our test this week. What we were looking at is the freezing and the melting of Parazene. Another way of putting this is a deodorant block. And if you look at it, it's got the consistency of maybe sugar or salt, and it's in crystal form. Okay, this is the hardened form, and at this point, all the particles in this substance are close together. They're vibrating. They're not moving a whole lot because there's not a lot of energy located inside of them. They need energy to separate from each other, and they need energy for the particles to move around. In order to do that, what I'm going to do is I'm going to take hot water from a kettle and pour it in and use this hot water bath to add the energy to the crystals that I need to actually get them to start moving. And if just to give you an idea, the temperature of the water right now is sitting at approximately, I think it's about 65 degrees, maybe 70 degrees Celsius. The actual melting point, by the way, for Parazene is about 50 degrees, and we're going to see how it actually works in the opposite. It actually freezes at that temperature too. So just this little bit of time that it's been in, you can already see liquid beginning to form at the bottom of the test tube. So we're going to give it a couple of seconds to allow it to bring it a little further closer to being completely melted, and then we'll show you what we're going to do with it afterwards. So we'll cut. We'll cut. And then, okay, we've left it in here for a couple of minutes, and it's still not fully melted. As you can see, there's still some solid Parazene in the test tube itself. But let's make the experiment work anyway. Right now, to the touch, it's pretty warm. You can actually feel a little bit of the hot water still on here. It's actually a very, very warm temperature, maybe about 50 degrees Celsius. However, if I spin it around a little bit and give a chance for the Parazene to cover.
Sorry.
However, if we spin it around a little bit and give a chance for the Parazene to go to other cooler parts of the test tube, you can see it's already beginning to freeze up here. It's actually beginning to form crystals, much like water does when it freezes. The temperature, actually, of the test tube is probably about 30 degrees Celsius, maybe even more, but it's beginning to freeze. So in other words, what's happened is the energy that was in the tube, the energy that was brought there by the hot water, that actually gave the particles enough energy to move in a liquid form, have now gone back to a solid form up here. And given a little bit of time, as the energy begins to wane, as the energy begins to disappear, it's going to all turn back into a solid. But the temperature of this is still well above 30 degrees Celsius. What does that mean? How does that work? And how could it be that something actually freezes at a temperature that actually feels very warm to the touch? Check out the questions that are on the Moodle pertaining to this. This is Lab 2.1, and see if you can figure it out over the next little while.